Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So today we are going to start with a new chapter, so that is gravitation. So till now whatever the mechanics part we did, so that's motion in a straight line, motion in a plane, and then Newton laws of motion, work, energy, power, and then so circular motion we did, the rotational motion. All these concepts will come under center of mass, right? So all these concepts will come under mechanics part. So every chapter we discussed in details, so you just have to follow the content and do some practice some questions from the reference books or from our PW library, your wish, and then do the previous year questions. Okay, so chala. So this chapter is again a important chapter for your competitive examination, and moreover this chapter will have the same similarity with the electrostatics. So in the second year, that means +2, you are going to study the electrostatic, the first chapter, electric charges and field, and electrostatic potential and capacitance. So whatever the concepts you are learning here, same concepts will be there in the electrostatics. Just you have to replace the mass with the charge there, and here the universal gravitational constant and the constant k there. That's it. Okay, so the formulas and everything you can just compare and study. Okay, so if you study now, it will be useful for the both the chapters. Okay, so concentrate guys. So, and I recommend whenever you are preparing for the competitive examination, so do these two chapters at a time, like gravitation and electrostatics, so that you can save time actually. Okay, chal. So today first lecture we are going to discuss the basics, that is Newton's law of gravitational force and gravitational field due to a mass and a different mass system. So our main objective is what is gravitational force today and what is gravitational field. Okay, chalo. So we'll do some questions as well, and you all know I just need your attention for the next 1 hour. Avoid all the disturbances around you guys. Just be with me for the next 1 hour, and at the end of the class it's very important to prepare your own short notes. Okay, chalo. So let's begin today's session with very high positive energy. So first let's see the basic. You have already studied the Newton's law of gravitation in the grade 9th level itself. So any two masses in the universe, so they attract each other. Let's suppose this is mass m1, this is mass m2. So there will be the force of attraction will be there between these two bodies. So that force of attraction is directly proportional to the product of the masses, and it's inversely proportional to the square of the distance between them, right? So the distance between them is, let it be r. So then we can write, so the force is equals to g m1 m2. So take out the proportional symbol and put the proportional constant, g m1 m2 by r square. So this is a formula, right? So where m1 and m2 are the two masses, and r is the distance between them, and g is called the universal gravitational constant. So g is a universal gravitational constant, right? So, and this force is always the attractive force. So whatever the gravitational force we are talking between two bodies on the earth, so it's a attractive force only, no repulsive force. Gravitational force is always attractive in nature, and its formula is this one, and it's a central force. So central force means it acts from this body center to this body center. Okay, and it's a vector, the force is a vector quantity. So here the force on 1 due to 2 we can write this, and this is a force on 2 due to 1. So they mutually attract each other. So these two forces will be equal in the magnitude. So the force on 1 due to 2 will be equals to the force on 2 due to 1. Their magnitudes will be same, but their directions will be opposite. So that means F12 I can write it as in the vector form, so which is minus F21. So they will be equal and in opposite directions. Okay, so this universal law, it is independent of the medium, very important. So it is independent of the medium. So what does that mean? So let's suppose if you placed two bodies in the air at some distance. Okay. So now you have placed these objects in some other medium. You have placed these objects in some other medium whose medium specific gravity, maybe it can be changed. So still the force will be same. Still the force will be same in two cases. Okay, the gravitational force. So that's what we wrote. So the universal law, it is independent of the medium. Okay. So its value you already studied in the grade 9th level itself. So the value is 6.67 into 10 to the power minus 11. So what are the units? So how can you write the units, guys? So let me tell you how to remember this simply. See, so we have got, so the force F is equals to G m1 m2 by r square, right? From here, if you need the units of G, so let's write G is equals to F r square by m1 m2. F r square by m1 m2. So from here, so units you can write it as, so the force units are Newton, and then distance square, which is meter square, by mass is kg and mass is kg, so kg square. Okay, so this we already discussed in the units and measurement chapter, the first chapter itself, right? So now one more thing, how do you write the dimensional formula? So remember its units. It's always easy to remember its units for the dimensional formula. So what are the units we have? Newton meter square per kg square, right? So the dimensions we can write it as, so Newton, which is mLt to the power minus 2, and meter square L square by kg square m square, right? So if you send it to the up, so it will be m to the power minus 1, L to the power 3, and t to the power minus 2. So this is a final dimensional formula for the gravitational constant G. Okay, clear? So that's what we wrote here. So this is the value and these are the units and dimensional formula I wrote. So next, it expresses the force between 2 point masses, always between the 2 point masses. So the gravitational forces are conservative force. Yes. So let's discuss this point. So the gravitational force, this F is a conservative force. So we have already discussed it in the work energy power chapter. So what's that? So the work done by a conservative force is independent of the path, right? So similarly here also the work done by the gravitational force is independent of the path. So the work done by gravitational force is independent of path. And so we can also write, so the work done in the round trip by the gravitational force is equals to 0. So the work done by the gravitational force in the round trip is 0. Clear? Understood, guys, everyone, this part? Chalo. So these are the simple basics, and the gravitational force between Earth and any body is called the gravitational force. Yes, so Earth and any other body, so towards the Earth, so we represent, there will be gravitational force between those two bodies. Okay, clear, everyone? Chalo. This is simply the basics. So let's take one simple question. So what's the question says here? Two astronauts are floating in gravitational free space after having lost contact, so with their spaceship. So the two will, so what we discussed in the previous slide, so the gravitational force is independent of the medium. So wherever you are, so there will be gravitational force between the two masses. So two astronauts are flowing in the free space after having lost contact with their spaceship. So the two will keep floating at the same distance? No, because two persons here, two astronauts, they will have some mass, right? Some mass will be there, whether it's more or less than on the Earth, so it will be some mass. So always two masses, they attract each other. So independent of the medium. So they move towards each other. So move away from each other. So will become stationary. No. So they move towards each other. Clear? Understood, guys? Sure. So let's move further. So let's take one more question here. So what's the question says? Two spheres of mass m and m are situated in air. So there are two masses. One is small m, the other one is capital M. So these two are situated in air. So the gravitational force between them is F. So the space around the masses is now filled with a liquid of specific gravity 3. So now this is in air initially. So now they are placed in some liquid. So they are placed in some other liquid now. So then, so the gravitational force is, so the gravitational force will be same. So the gravitational force is independent of the medium. Okay, remember that point. So the gravitational force is independent of the medium. Independent of medium. So this is the actual difference between the electrostatic force and the gravitational force. So the formulas and everything will be same. So but the gravitational force is only the attractive force. But the electrostatic force, so which is the attractive as well as repulsive. Okay. And gravitational force is independent of the medium. But the electrostatic force is dependent on the medium. If the medium changes, the electrostatic force also will change. Okay, so that you will study it in grade 12 level. So just remember my words at that time, so you can relate these two. Okay, chalo. So let's move further. So what's the third question says here? So two identical spheres are placed in contact with each other. So there are two identical spheres. So that means they have same mass and same radii. So then these are two masses which are in contact with each other. So let's suppose this has a mass m, and then so each one has a radius r. Fine. So then the force of gravitation between the spheres will be proportional to. So they are asking what's the force of gravitational force they are asking. See, so the gravitational force is F is equals to G m. Let's suppose mass of this is m and mass of this is m. So m by r square. M by r square, right? So now see, so what's the distance between what's the gravitational between the spheres will be proportional to. Okay, fine. So in terms of r we should write. See, so what we can write here it is, so this will have the density rho. So this will have the density, same density rho. So the density is equals to mass by volume. From here the mass is equals to density into volume. So the first one's density rho into, so what's the volume of that? 4 by 3 pi r cube, right? Sphere. So and the second one also will have the same mass. So now what I am doing is, in place of mass, so most of the students commit mistake here itself. So they write it is directly proportional to 1 by r square. F is directly proportional to 1 by r square. So but these two are the identical sphere. They have some mass and some density. So write that mass in terms of density so that you will get extra r values. So that G into, so m, in place of m what I am doing is rho into 4 by 3 pi r cube. Okay. So into, so the other mass is also rho into 4 by 3 pi r cube. So remaining all you can just keep them constant. So we just need the relation between force and radii, the distance r, right? So radius of the sphere actually. So F is equals to, actually here you can put 2r whole square, because the distance between their centers is 2r. Okay, so as we only need the r value, you can just take it r only. So see here in the numerator r cube into r cube, which is r to the power 6, by in the denominator r square, so which is nothing but r to the power 4. So simply I am writing, so not equals to, here you can put proportional, so that the force is directly proportional to r to the power 4. So the force is directly proportional to r to the power 4. Option 4 is the correct one. So most of the students commit mistake here itself. So they write F is inversely proportional to R square. So they choose this option, option C. No. Okay. So you have to represent that mass in terms of the density and volume, so that you will get this R values in the numerator as well. Done? Clear? Chalo. So let's take the next question, guys. So what's the question says here? First read the question. So two particles of equal mass go around a circle of radius r under the action of their mutual gravitational force. Okay. So of attraction. So find the time period of each particle. Two particles of mass, equal mass, go around the circular path of radius r. See here. So let me take, so this is a circle of some radius r. Okay. So then, so this is a circle of radius r. So now there are two particles of mass m. So let's say each one mass is, let's consider, so one mass is here m and the another mass is here. So they are moving in the circular path. So what's the distance between these two masses now? 2r is the distance between these two particles. And then they are asking what's the time period. Okay, see here. So first let me take this off better. Let's write this one only. So between these two masses, so there will be gravitational force. They are moving in the circular path. So between these two particles there will be, so the gravitational force, yes or no? So what's the gravitational force? So they will be attracted towards each other, Fg. Yes. So if it is acting on this, if Fg is acting, so on this Fg will act. Yes or no? So then, and one more thing, so there will be, as they are revolving in the circular path, so shall I say that there will be centripetal force, right? So this centripetal force is nothing but some other force will act as a centripetal force, right? So here the F centripetal will be equals to the F gravitational. The F centripetal will be equals to, so the F gravitational force. So they both will be equal. So this statement, have you guys understood? Everyone, if you understand this statement, you can do it easily. So just write the equations now. Just write the equations for that. Simple thing. You just have to write the formulas. That's it. What are their masses? What are their masses? M and M. So in the options also they gave M only. Centripetal formula, centripetal force formula. F is equals to mr omega square or mv square by r. So they are asking us the time period. So shall I say the time period is equals to 2 pi by omega. Omega is equals to 2 pi by t. So then omega is t is equals to 2 pi by omega. So I'll write centripetal formula. So mr omega square better. Mr omega square. From there I can find the omega and then I'll substitute it here so that I'll get the time period. This is the overall idea. So now what's the gravitational force between these two masses now? So the gravitational force will be equals to, so g into, so the two masses are, one is m, the other one is also m. So what's the distance between them? These two masses are revolving in the circular path. So at any instant, so the distance between them will be 2r. Yes or no? The diameter. Understanding? So then, so we can write this as mr. So let's write here also the capital R itself. Mr omega square. So from here, so m cancel, 1m cancel. So then I can write r omega square is equals to gm by, so 4r square. 4r square. So from here actually we need omega. So omega square is equals to gm by 4r cube. Right. So omega is equals to square root of gm by 4r cube. Yes. So now let it be. So now I have to find the time period. So let me write it here. Simple calculations. Do it on your own, guys. So time period t is equals to 2 pi by omega. So 2 pi by omega. So which is nothing but 2 pi by omega. So what is omega? Root over gm by 4r cube, right? So we can write it as 2 pi into root over 4r cube by gm. So how the options are? Options are r to the power 3. Okay, so you can take 2 out. 4 root 4 is 2, so 2 will come out. 4 pi into r to the power 3 by 2, r to the power 3 by 2 by root gm. So is there any option like this? So 4 pi, so not this one, not this one. So 4 pi by root gm into r to the power 3 by 2. So yes, option 3 is the correct one. Clear? Understood, guys? Simple concept. This we already discussed in the which chapter? Circular motion chapter, right? Chalo. So the next one more question. So the question number 5. So two particles of equal mass go around a circle of radius r under the action of their mutual gravitational force. Only the force between them is the gravitational force. So then the speed v of each particle will be, again same question. So instead of using the mr omega square, you can use the mv square by r between the centripetal force. Here one mass is there m, and here one more mass is there m. So the distance between them is 2r. So here also the centripetal force will be equals to the gravitational force, the F gravitational. So we can write the formula. So what's the centripetal force we can write? What's the centripetal force? mv square by r I am taking, because I need velocity now. Previously I need time period, so that's why I wrote in terms of omega, so that I can find the time period from there. So here I need velocity. Directly I'll write the centripetal force is mv square by r is equals to, so the gravitational force between these two masses, so the radius is 2r, the distance between them is 2r, so and mass gm into m by, so distance is 2r whole square. That's it. So from here, so what we can do, m gets cancelled, so v square by r is equals to, so gm by 4r square, 1r gets cancelled. So we need v is equals to root over gm by 4r, r. So 1 by 2 you can write. So 4 if you take out, 1 by 2 into, so root over gm by r. So this is a velocity v, 1 by 2 into, so gm by r no, so 1 by 2 into root over gm by r, correct? 1 by 3 no, 1 by 4 no. Clear? Understood, guys? Chalo. So let's move further. So let's take one more question. So what's the question says? So if the gravitational force between two objects were proportional to 1 by r, not 1 by r square, so where r is the separation between them, so then the particle in circular orbit such that the force would have its orbital speed v proportional to. So see here, again same question. See, there are two objects. Here is one mass m and here is one mass m, let's suppose. So obviously the distance between them will be like this, 2r. So then two objects where the gravitational force is proportional to 1 by r. So here the F gravitational, the first thing is, if they are moving in the circular path, so the F gravitational will be equals to, so the F centripetal. So now the gravitational force, generally we write, so G into, so the two masses m into m by, so here it is directly proportional to r. It is it is proportional to 1 by r. So generally we write 1 by r whole square, right? 1 by the distance is 2r whole square. So but simply here from here to here it is r, and from here to here it is r, so that it will be simply 2r you can write, because in question they clearly mentioned it's not 1 by r square. In the gravitational force formula you should not use 1 by r square, you should use 1 by r. So as the distance is from here to here r and from here to here r, so you can just take 2r, so which is equals to, so the centripetal force which acts towards the center is obviously mv square by r, right? So from here r gets cancelled. So they are asking So the velocity is proportional to r. So the velocity is proportional to, so I can write r to the power 0. There is no r term, right? If it is r square, so there might be some r term, but here r and r gets cancelled. So there is no r term. So v is directly proportional to r to the power 0, which is nothing but 1. So option B is the correct answer. Done? Simple questions these are all. Done, guys? Chal. So let's move further. So the principle of superposition of gravitational forces. Yes. So due to one mass, the gravitational force, let it be F1. So now due to n number of masses, so there are, so m1 mass is here, m2 mass which is at a distance r2, m3 which is at a r3, and mn which is at a distance rn. So then the gravitational force, the net force will be simply, so the vector sum of all the forces, F1 plus F2 plus F3, so till Fn. Understood, guys? So this is the gravitational force. F is equals to, so what is force F? So it is gm1 m2 by the distance between them. That's it. Clear? So we'll do questions so that you'll understand better. Let's take the question number 7. So what's the question says here? So read the question, guys. So 3 masses each equal to m are placed at the corners of a square of side A. Calculate the force on unit mass at the 4th corner. So there are 4 corners of the square. So consider this is a square. So here mass m is placed, here mass m is placed, here mass m is placed, and here so unit mass is placed. So that means let's suppose 1 kg mass is placed here. So now we have to calculate the force of attraction on unit mass at the 4th corner. Let it be the 4th corner. See, on this 1 kg mass, due to all 3 masses, what are the forces? What are the forces between these two? This is side A, side A, side A, and side A, right? So try to understand the simple thing. So between these 2 masses, there will be the force. Between these 2 masses, there is force, right? And then between these 2 masses, again, so the force will be there. So let it be the force F1, let it be the force F2, and then between these 2 masses, so the force F3. So I can write, so we know the formula. So the F1 is equals to the force between the first one and second one is F1 we considered. So which is G into, so mass is 1 kg, the other mass is m, into the distance between them is a, so a square. So which is gm by a square, let it be. So then, so let's find F2. So the force F2 between these 2 bodies, G into, so the mass of one body is 1 kg, the other one is m, by, so what's the distance between those 2? A, so a square. So which is gm by a square again, right? So then let's find the force F3, so between these 2. So how do you find? So G, one mass is 1 kg, the other mass is capital M. So here the distance is not a, so this distance will be the diagonal. So if it is a and it is a, so this distance will be obviously a root 2, basic maths, right? So the distance here it is a root 2 whole square. So here it's going to be gm by, so 2a square. Yes or no? Root 2 whole square is 2 and a whole square is a square. So gm by 2a square. So let me do one thing. Let me consider this gm by a square as force F. So here also gm by a square will become force F, and then here gm by a square force F by 2 it will be. So gm by a square is force F by 2 it will be. Now, so see here overall, so let me do it in the next slide. So overall, so I can say that this is a 1 kg block. So on this, so the force F is acting this side and the force F is acting this side, right? And then this will become the force F by 2. Here the force F by 2 is acting this side. The force, this is F by 2. So now can I find the resultant of these two forces F and F? So the resultant of these two forces will be F root 2. The resultant of these two forces F and F, so the resultant will be F root 2. Yes, so now I can write here, so the net force, the F net will be equals to, see here, F and you already studied it in the vectors, right? If there are two equal vectors and the angle between them is 90 degrees, so the resultant will be, so that vector into root 2. So here force into root 2. So now they both are in the same direction, F root 2 and F by 2. So they both will get added. So F root 2 plus F by root 2, F by 2. So here I am taking F common. So it will be root 2 plus 1 by 2. Root 2 plus 1 by 2. So let me substitute what is F here. So Gm by a square into, so root 2 plus 1 by 2. Root 2 plus 1 by 2. So this is a net force. So select this option now. So Gm by a square into root 2 plus 1 by 2. Root 2 plus 1 by 2. Root 2 plus 1 by 2. Gm by a square root 2 plus 1 by 2. Yes, fine. Yes, we got the answer. Done. Next. So try to solve this question, guys. So what's the question says? The question number 8. So three particles of each mass m are placed at the three corners of an equilateral triangle. So each of them having mass m. So consider, let's suppose this is a triangle, equilateral triangle, and three masses are placed at three corners of the triangle. So the center of the triangle is at a distance x from either corner. So here is the center, so which is at a distance x from this corner, which is at a distance x from this corner, which is at a distance x from this corner. Okay, so if a mass m be placed at the center, so here if you place the capital M mass, so what will be the gravitational force on it? So understand the question. What is the gravitational force on the capital M mass? So due to all these three masses, due to all these three masses. See here. So let me write. First thing is, so they are all at the same distance. So I can write, if I write just their magnitudes, so the magnitude of each one will be GMM, between these two, GMM by the distance x square. So that means here the force F will act this side between these two, and then between these two, so the force F will act this side, right? So between these two, so the force F will act this side, same GMM by r square, x square, because the distance is x from the either corner. All the corners the distance is x, and these all masses are same, and at the center capital M mass is there. So this is fine. Now, so if I write the diagram here, see here, so this side the force F is acting, and then this side the force F is acting, and this side again the force F is acting. Now, so let's do the simple maths here. So shall I write, so this whole angle is 60 degrees in the equilateral triangle, so that this angle will be 30 degrees. So I can write this angle will be 30 degrees and this angle will be 30. So this is 30, 30, 60. So then, so if I write, if I draw a horizontal line here, so this will be again 30 degrees, and then this will be again 30 degrees. Yes or no? Why? Because if it is 30, this is 30. If you draw a line here, horizontal line parallel to the base, so then this angle and this angle will be the alternate angles, this one and this one. So same thing I wrote here. Okay, so now, so we have got, let's write the components now. So the force F is that side. So this force will have two components. One is F cos 30 this side. This force will have two components. So as 30 degrees is this side, so we can write this component will be F cos 30, and the down component will be F sin 30. Right, so that's done. Next, so we can write the other one. So this one F cos 30. For this one there will be again two components, F cos 30, and then so downside again we get F sin 30, right? Chalo. So now shall I cancel this F cos 30 and F cos 30 because F value is same for everything. So and then F cos 30 gets cancelled. And so one more thing here, these two will get added. So F sin 30 means F by 2 and F sin 30 is F by 2. Sin 30 is 1 by 2, right? So if you add F by 2 plus F by 2, so the overall force will be F downward. So that means this overall force downward is F. So this F and F again gets cancelled. Upwards there is force F, right? So they are same in magnitude, opposite in directions. So that means horizontally there is no force and vertically there is no force. So at the center, the net force at this point will be equals to 0, I can say now, right? So that's what I wrote. So the net force at the center will be 0. Clear? Understood? So here one statement you can write, that is force on a mass at center of symmetrical mass distribution. So what is the symmetrical mass distribution? So here mass m is placed and here mass m is placed and here mass m is placed. So this is a equal distribution. So that's a symmetrical mass distribution. Now if we have to find, so force on this mass which is placed at the center, so the F at the center will be equals to 0 due to the symmetrical mass distribution. So any symmetrical mass distribution you can take, square or hexagon, your wish. So but at the center it will be 0. So if you want you can take the square also, but equal mass distribution should be there. So here mass m and here mass m and here mass m and here mass m. Okay, so equal mass distribution, and then here it is, this is going to be capital M mass. So if you have to find the force on capital M mass, net force on the capital M mass, so it will be equals to 0 again. Okay, so done guys, understood? So remember this statement. Okay, chalo. So let's move further. So the next question, let's go for the gravitational field. So till now whatever we discussed, that's a gravitational force. Okay, so now what is gravitational field? So it's a space around the body in which any other body experiences a force of attraction is called the gravitational field of the first body. So simple, if you place an object, so this object, so within the vicinity around this object which can attract the other objects is called the gravitational field. This is the first object, let's suppose. So now you have placed some other object here. So now it is able to attract this one. This object is able to attract this one. So that means its gravitational field is there around this body, right? So whatever the field that is around this body is called gravitational field. So if you place some other body very far, so it's unable to attract, this body is unable to attract the other body. So then we can say that its gravitational field is limited to this point only. Its gravitational field is not reaching the other point. Okay, so it's a space around a body in which any body experiences a force. Okay, so and then, so what is the intensity of gravitational field, which we denote it with E? So in the class 12th we again come across with the intensity of electric field. So there also it is denoted with E only. So it's also the vector quantity. So the intensity of a gravitational field at a point, so at this point if I have to define what is the intensity of gravitational field, so defined as a force experienced by a unit mass at that point. So now if I place a unit mass here, so how much force this unit mass is experiencing? So due to, so the capital M mass, let's suppose due to this mass, how much force this unit mass is experiencing, So that is called the intensity of the gravitational field. Simply I can write the formula. The intensity of gravitational field is equals to, so the force upon, so how much force it is experiencing per, so that mass, so F by M, that's it. So the force upon mass. Okay, so what are the units now? What are the units you can write? So the force Newton and mass kg. So Newton per kg. So the force Newton per kg. Understood everyone? So note that point. I'll have just some water. Chalo, thanks. So done. Newton per kg. So you can also write it as, so Newton is nothing but again force into mass, right? Sorry, mass into acceleration. So mass is kg, acceleration meter per second square, by again you can write kg. So here kg gets cancelled. So again you can write it as meter per second square. So that's also fine. So or else see here. Let's write here. So Newton per kg, or I can also write meter per second square. Done? Na? Chalo. Next. So now the gravitational field due to, so the point mass. So here is the mass m. So what is the gravitational field due to this mass m? So at a distance r, which is at point P. Okay. So the gravitational field at point P is equals to, wherever you have to find the gravitational field, what we do is we just place a unit mass there, and then this unit mass, how much force it is experiencing due to this mass. This unit mass, how much force it is experiencing due to this mass, because this mass will have some gravitational field. So when in this gravitational field, this body's gravitational field, if we place some other unit mass, small mass, unit mass, so it will experience some force, right? So that force upon that unit mass, the force experienced by that unit mass, by that unit mass will give the intensity of gravitational field. Okay. So what is the force experienced by this? We already know. What's the gravitational force experienced? What's the gravitational force between these two? So we can write G, capital M, small m, by, so the distance between them is r square. So by the small m, so I can write, so small m cancel. So the gravitational intensity, the gravitational field intensity is, so at point P, G m by r square. So remember this one. So the gravitational field is also inversely proportional to the square of the distance between them. Is also square of the distance between them. In electric charges and fields, you will study the intensity of electric field. So which is equals to, so kq by r square. Here it is gm by r square. That's it. That's the only difference. Clear, guys? Understood this part? Chal. So it's also a vector quantity, guys. So this is the vector quantity. It will have the direction. It's a vector quantity which will have the direction. So this is done, and gravitational field due to the point mass, so gm by r square, you should remember the formula. And if you have to find, so the net gravitational field due to, so the system of masses, so how do we find? So the E net, the net gravitational field will be equals to, so here I can write E1 plus E2 plus E2 plus E3, so till En. E3 plus till En. Okay, understood? So let's suppose, so there are two, we'll do the question so that you'll understand. So just write this one. So the net will be equals to this one. Done? Na? Clear? Chalo. So let's move further, guys. So the question number 9. So what's the question says here? 3 particles each of mass m are kept at vertices of an equilateral triangle of side L. So then the gravitational field due to these particles is, see here. So what we have to find? This is an equilateral triangle. So 3 particles of mass m here, m here, and m here are placed at the vertices of an equilateral triangle, so of side L. So then the gravitational field at the center, so here the gravitational field at the center, here we have to find. So what we do, wherever you have to find the gravitational field, so we just place some small mass, unit mass here. So the gravitational field between these two masses will be this direction. It's a vector quantity. So the gravitational field, so on this particle will be in this direction. So the gravitational field between these particles So field intensity, the gravitational field intensity will be in this direction. So again the same thing, previous question. So here E, and here E, and here E, right? So this side we will be having, so if you draw a line here, so this is 60 degrees, right? So then if you draw a line here, so this will become 30 degrees and 30 degrees. So I can write, so this angle will become again 30 degrees, because this total is 90, this total is 90. So right, so and then this angle will be 120. So obviously this should be 30 and this should be 30. So this angle will be 30 degrees and this angle will be 30 degrees again. So that we'll be having E cos 30 to this side, and then E cos 30 to this side, and then so here E sin 30 and E sin 30. E sin 30 due to this one and E sin 30 due to this one. Components just I am writing. So you can simply write these two gets cancelled and summation of these two will be equals to E. So the net gravitational field or the net gravitational force, so due to the symmetrical mass distribution at the center of its body will be 0. So either the net gravitational field or the net gravitational force at the center of a symmetrical mass distribution will be 0. You can note this down. Okay, previously I already wrote that. Where is, so here, so for force on a mass at center of the symmetrical mass distribution. So instead of force you can also write the gravitational force on a mass which is placed at the center of a symmetrical mass distribution is again 0. Okay, clear? Chalo guys, so let's take the one question. So 2 point masses K1 10 kg and 1000 kg are placed at a distance 1 meter apart. So there are two masses. So one is let me take another color. So one is 10 kg, the other one is the 1000 kg. So here is the 1000 kg mass. So which are placed at a distance 1 meter apart. So they are placed at a distance 1 meter apart. So at which point on the line joining them will gravitational field intensity be 0? So here at which point, so we don't know at which point. So first let's do by the standard procedure, then we'll go for the shortcut. So I'm considering, so some x distance from the small mass, the x distance, see the gravitational field due to this one will be this side, and the gravitational field due to this one will be this side. Yes or no? So due to this one this side, and due to this one this side away. Now you can simply find the gravitational net gravitational field. Somewhere it will become 0, because its gravitational field and its gravitational field, when they are equal, so it's a vector quantity, so the net will be 0. So at which distance we don't know. So from smaller mass I am considering this distance as x. So here, and this distance will become 1 minus x, because the total distance is 1 meter, right? So it will be 1 minus x. So now, so they said equal 0. So net gravitational field 0 means, so whatever the gravitational field due to between these two, so will be equals to the gravitational field between these two. So I can write, so g into, so 10 kg mass by so the distance between them x square, gm by r square, right? So here also g into, so 1000 kg mass by, so the distance is 1 minus x whole square. This gravitational field E1, let it be, so it should be equals to the E2. So the E1 is equals to E2 I am writing. E1 is between here these two, so and E2 is between these two. Here I wrote the same thing. So here the g into 10, so I can write it as 10 0 0 cancel, g cancel. So I can write 1 by x square is equals to 100 by 1 minus x whole square. So let's do the simple calculations here. So 1 by x whole square I am writing this one. So here let me write, so 10 by 1 minus x whole square, 10 by 1 minus x whole square, 1 minus x whole square I am writing. So if you keep the root either side, I can write this as, so I can write this as 10x, because square gets cancelled. So 10x is equals to 1 minus x. So bring x to this side, 11x is equals to, so 1. From here x is equals to 1 by 11 meters. So that means at a distance of 1 by 11 meters from the 10 kg mass, so the gravitational field intensity can be 0. So at what distance? So at 1 by 11 from where? So from 10 kg mass, from 10 kg mass. Okay, so for these questions you can also use the shortcut. So what we call it as null point. Null point. So null point is the point where, so the net gravitational field is 0. The net gravitational field, the net gravitational field, okay, I'll write the general formula, net gravitational field 0. So I'll write the general formula. Let's suppose there are two masses, let it be capital M1 and then capital M2. So and the distance between them is, let it be the distance L. So the gravitational field, the net gravitational field will be 0 at a distance x from the smaller mass. Okay, so I'll write the statement. So the net gravitational field, the net gravitational field will be 0. The net gravitational field will be 0 at a distance x from the smaller mass. At a distance x from the smaller mass, at a distance x from the smaller mass M1 is given by, so that x distance is equals to, so root over M1 by root M1 plus root M2 into, so the distance. So L is the separation between two masses. So what is L here? L is the separation between two masses. So the L is the separation between the given two masses. That's it. Clear? Understood point? Understood this point, guys? So now you can just simply take the previous question. You can do it by this method. So I'll write, I'll do it here itself. So let me do the method 2. Follow the method 2 for this. So the, let's consider this distance is x from the smaller mass, which is root M1 by root M1 plus root M2 into the distance L, right? So what is root M1? M1 mass is 10 kg, right? So root 10 kg by, so M1 is root 10 plus M2 is root 1000. Done. So fine. So into the distance L. So the total distance L is 1. So what I am doing is, so let's write root 10 by, so here root 10 into, so 100 into 10. Inside the root I can write 100 into 10. So 100 comes out of the root, so which is root 10 again. So this distance 1, so you need not to take. So root 10 by, so in the denominator I am taking root 10 common. So which will be 1 plus 10. I am taking root 10 common, so that 1 will be left here and 10 will be left here. So root 10 cancel. 1 by, so 11. So same answer we got in the method 2. So at a distance 1 by 11 from where? From the smaller mass. This x distance is from the smaller mass. Understood, guys? Clear? Chalo, so done. So this one you should remember. So then this question you can take it as a homework. Can you guys take this as a homework? The net gravitational field you have to find. So figure shows a system of point masses placed on x-axis. So M mass is placed at a distance 1 meter, then 2 meters, then 3 meters, then 4 meters, then 1 meter, 2 meter, 4 meter, 8 meter, like that. So if you want to write what is the net gravitational field intensity at origin, here we have to find. So the net gravitational field E net is equals to, simply you can write E1 due between these two, and E2 from here to here, and then E3 from here to here, then till infinity. Yes or no? So that the first one you can write, so G mass M, G into M by the distance is 1 square is 1. So plus the second gravitational field is G into mass M by, so this is 2 square, which is 4. So then the next one G M by this distance 4, which is 16. So up to infinity, right? So if you observe, these are in the GP, this sequence is in the GP. So right, so the given sequence is the GP. So summation of infinity terms in the case of GP is, so a by 1 minus r, a by 1 minus r. So where a is called the first term, a is the first term. See, this is a simple math you should understand, guys. So this r is a common ratio. So simply you can find that now. So what is a? A is equals to gm by 1. The first term is this one, and the common ratio r is what? Gm by 4 by gm by 1. Yes or no? So which is nothing but, so gm cancel, which is 1 by 4. So now the s infinity, so the summation of infinity terms will be equals to, so a is gm by 1 whole by, so here it is 1 minus r, which is 1 minus 1 by 4. So which we can write it as gm by 1 by 1 by 3, 1 minus 1 by 4 is 3 by 4. So we can write it as gm by 1 into 4 by 3. So which is 4 gm by 3, simply 4 gm by 3, 4 gm by 3, option D. So the concept is simple, but you should have the knowledge of basic maths here. So you should know what is this, you should know this sequence is in GP and what's the summation of infinity terms in the case of GP, geometric progression. Clear, guys? Done? Chalo. So we don't need another slide here, so let me delete this part. So let's go for the gravitational field at P due to a uniform rod of mass m and length L. So simple concept again. So here, due to the continuous mass distribution we are talking about, due to the continuous mass distribution. So till now we discussed what is the gravitational field or gravitational force due to the point masses. Yes. So now due to the continuous masses, if it is a uniform rod of length L and mass m, we know that its mass is distributed all over the length L. Yes or no? So now we have to find at a distance P what is the gravitational field due to this whole rod. Previously we know only due to the point mass. Only due to the point mass, which is at a distance E is equals to gm by r square. But here it is a continuous mass distribution. So then again what we do? The same simple procedure. So we know due to the point mass, so we cut this into some n number of point masses. So this distance is dm. Let's consider this distance is dm. Yes or no? So if this distance is dm, so this, let it be some distance x. Yes or no? So this has some length dx. This has some length dx. So then what we write here? So the solution. So this linear mass density, we know that lambda is equals to mass upon the length. We already discussed this. So let the small mass dm and small length dx. This small mass has dm and this small length has dx. So now, so what's the gravitational field due to? So that small mass dm, which is equals to de. So what's the formula for de? G into dm by x square. The distance between them is x square. G into dm by x square. So now if we need the whole thing, so we then do it from integration of g dm by x square. Integration of g dm by x square. So here integration of de is e. This is a e net. So g we can take it out. So the integration of dm into dm by x square. So the mass is varying. From where to where we should do the integration? From this end to this end. So here if you cut a small part and if you cut a small part, so from this end to this end. So which is this end is at a distance a and this end is at a distance from here to here it is L and from here to here it is A. So from A to A plus L. From A to A plus L. The integration you should do. So here you should cut the small part here, here, here till here. Okay. So then So I can write E is equals to G into, so the integration of A and A plus L in place of dm. So let me do this basic thing here. So lambda is equals to dm by dx. From here the dm is equals to lambda dx. Dm is equals to lambda dx. So dm is lambda dx by x square. So here g into, so the lambda is constant, take it out. So the integration of 1 by x square into the integration of, so 1 by x square, let me write it here, 1 by x square into dx. So let me do it in the next slide. So here the net gravitational field E is equals to, so g lambda integration from A to A plus L, right? So 1 by x square into dx, right? 1 by x square into dx. Yes. So what's a 1 by x square integration? You already know. So minus 1 by x, right? So this is minus 1 by x. From where to where? A to A plus L. What is the integration of 1 by x square, guys? Integration of 1 by x square into dx. So we write it as integration of, so x to the power minus 2 into dx, right? So which is nothing but x to the power minus 2 plus 1 by minus 2 plus 1. So then we write x to the power minus 1 by minus 1. So what is this one? Minus 1 by x. The same thing I wrote here, basic maths, right? So just be thorough with the basics, guys, always. So here I can write, so g into lambda, so minus, so substitute the upper limit 1 by A plus L minus of minus 1 by A, right? So then g lambda into, so this will become, so plus 1 by A, I'll write 1 by A plus L. So from here g lambda into A plus L. So I get A plus L here minus, so it goes A plus L and here A, so that A gets cancelled. So the net gravitational field, so the net gravitational field E net will be equals to, so we left with g lambda L by A into A plus L. Let's eliminate this lambda also. So we can put lambda is equals to, so the mass upon length. Yes or no? So from here I am writing g into, so in place of lambda, mass upon length L, A into A plus L into L. So L cancel. So it's going to be gm by A into A plus L. So this is a net gravitational field due to the continuous mass distribution of uniform rod, which is of mass m and length L, gm by A into A plus L. That's it. gm by A into A plus L. Clear? Understood this part, guys? Chalo. So let's move further. So we don't need another slide here. So let's delete this. So now what is the force on a gravitational field? Force on a mass which is placed in the gravitational field. Let's suppose, so this is a gravitational field. So in this gravitational field you place the small mass m. So then it experiences the force. It experiences the force. So what is that force? So that force is equals to, so that mass into the gravitational field. So that force is equals to mass into the gravitational field. F is a force here, and then so E is a gravitational field, the magnitude of the gravitational field or the intensity of the gravitational field, or the gravitational field intensity you can write. Done? Clear? Chalo, simple thing. So let's take one question, guys. A particle of mass m is placed at a distance d from one end of a uniform rod with length L and mass m as shown in the figure. So this is a uniform rod of length L and mass m. From this rod's one end, so a small mass m is placed. Now we have to find the magnitude of the gravitational force. See here. So they are asking us to find what is the gravitational force. So the gravitational force is equals to, the gravitational force is equals to, so m into E. So at this point, so due to this rod, the gravitational field, what is the gravitational field? So that E is equals to, just now we discussed, so due to the continuous rod, so gm by A into A plus L, actual formula. So here we can write E is equals to Gm by, so here in place of A they gave D, so D into D plus L you can write. This is E. Now actually what is required? So the force F. So the force F is equals to M into E. What is M? Small m only. Into E we can write Gm by D into D plus L. So simply it becomes Gmm by D into D plus L. D into D plus L. That's it. Right? Understood, guys? Chalo. So this is due to the continuous mass distribution. So of rod M and which is of rod mass M and length L. So if the same rod is bent in the form of some arc, if it is bent in the form of some arc, so now if you have to find, so the gravitational field at this point O. So what is the gravitational point at point O due to the continuous mass distribution? Again we do the same thing. Here we cut the small mass dm, again here we cut the small mass dm, and then we integrate that. So we are not going for the derivation here. So directly you can remember the formula. So the E at this point O will be equals to Gm by r square phi into 2 sin phi by 2. So where this phi is in radians we take. So this phi is in radians we take. Okay. So this formula everyone should remember, guys. So for example, so if a rod is bent in the form of a semicircle, for example a rod of mass M and length L is bent in the form of a semicircle. This is a rod of mass M and length L. So it is bent in the form of a semicircle. So then here if I have to find the gravitational field, okay, so due to this rod, so then the E at this point O will be equals to, so Gm by r square, in place of phi, what we can write for the semicircle, the phi will be equals to, so 180 degrees, right? So it is the phi here is equals to 180 degrees. So here you can write, so 180, which is nothing but pi into, so 2 sine, what is this one? What is this one? In place of pi you can write 180 by 2, which is 90 degrees. Sine 90 is 1, right? So this whole thing will become, so 2 Gm by r square phi, 2 Gm by r square phi. So take this in radians always, and this in degrees or radians, your wish. Degrees or radians. Understood, guys? Same simple thing, just you have to remember the formula. Okay, so if you have to find, let me do 1 or 2 questions. So let's suppose if a rod is bent in the form of a quadrant like this, if a rod is bent in the form of a quadrant like this, so now if I have to find the gravitational field at this point O, so this rod is of mass M and length L. So what is this phi will become? So this phi will become for the quadrant 90 degrees. So now E at O formula we know. What is that? Gm by r square phi. Are you guys following? Simple thing, just formula based one, into, so 2 sin phi by 2. Again the same formula will come in the electric charges and fields chapter, guys. So there you write kq by r square phi into, so 2 sin phi by 2. Okay. So here Gm by r square. So what is this 90 degrees means? I can write it as pi by 2. 90 degrees is pi by 2. So into 2 sine. So this will be 90 by 2. So sine 45 degrees. So we can write this as, this 2 will go up. So 2 into 2, 4 Gm by r square pi into sine 45 is 1 by root 2 we can write. So this is a E naught. So our quadrant or semicircle fine, but if you have to find for some other length, some other arc, so which is making some angle, let's suppose this is of the rod which is bent in this form. So then if we have to find the gravitational field at this point O, so this is of mass M and length L. So the gravitational field at point O will be equals to, so Gm by r square phi into 2 sin pi by 2, 2 sin pi by 2. So simply this angle, let's suppose I am taking some 60 degrees. So you can write gm by r square. So 60 degrees means, let me take pi by 3. Pi by 3 into 2 sine. So 60 by 2, 30 degrees here, right? So then, so these two gets cancelled. Sine 30 is 1 by 2, 1 by 2 cancel. So here 3 gm by r square pi. 3 gm by r square pi. Clear? Done, guys? So just you have to remember the formula, that's it. Okay. So this is all about the today's lecture. Okay. So in the next lecture, we'll meet with the new topic. So till then, keep studying. All the very best, guys. Bye. Take care.